Let me share the screen. Today's a big day. Um, yeah, it's a big one. Uh, Inclined planes is a big part of this. Hold on. My wife's calling. Hey, hey, hey. uh, 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 Mudslide. Oh, oh, I don't care. Just give me whatever you think I'll eat. Like cream and chocolate and stuff like that. Yeah, cool. All right, bye. Sorry about that. We'll edit that out. All right. I guess we're giving free coffee to teachers. I already had 3 cups of coffee. What are you talking about? All right. I did get some of that free pizza though. So here we go. Today's important. What I'm trying to say. What we talk about in class. We got books. I gave away magic books today. Books on magic. Pretty cool. And a book on. I gave away a book on composers. A whole book on composers. Strauss, Beethoven, Bach, all those guys. Their biographies. Pretty cool. Um, Today, if you want to keep up with the in-person students, you'll have the front of 6.5 done. Now I didn't require 2C or 2D, and so the ones I did require were all like 1 or 2 minute problems. Boom, 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 and that was a total of 15 minutes. But I was shocked at how many students did the whole daggone thing. I, I cannot tell you. I almost teared up in third hour at these students, and you all too. You guys are some of the hardest workers. Here we are in May, and you are still in there swinging. That's why I'm the envy of all teachers at Norman High, because I got the best students. I handed back the PP, which is the practice problems from test 6A. That you see your scores. Um, I have your folder up here for the front porch. I will stick that back in the don't no reason to come get that. But when you come by later on, say later on in May, you might that'll be in your file. Tonight I'm going to start grading test 6A. I've been doing other stuff. But now that we have finally incorporated, we finally have a LLC, I can start to do other stuff. Okay. I'll have an advertisement for the June for Ask Me Learning. We'll have an ad this week. We'll have a new website up, I think Thursday or Friday night. Here's the key to number one, 641. I posted this last night uh, on the um, on the screenshots, but I'll post it again tonight. This is done by a student with much better handwriting than me a couple of years ago, about 3 years ago. And the answer is 265 knots. And when I went around the room, only about 4 or 5 students had the answer correct. So probably some little thing you're doing. That's probably the hardest part right there. Knots squared dot hour squared over miles squared. And you had to square the 1.15. Anywho, that don't worry about that. Uh, we'll get back to 6.4 probably tomorrow or maybe the next day. We'll slowly get through 6.4. I mean, if you want to do the whole thing, you can do it because you're going to eventually have to do it. But in fact, for the virtual students, for you all, I think we're mostly virtual here. Any in class kids? Hold on. Ah, oh. Let's see who's all here. Okay, so we're all just virtual. Okay, so for you all, you will submit 6.4 next week, probably later in the week. So you got a long time, but if you want to kind of work on that one problem a day or something, we'll eventually submit it. That's what we did That was a freebie. We did that yesterday. There's the front of 6.5 that they all did. I'm telling you, 50% of the students just did the whole thing. Crazy. Or they tried it. Now the back of that one, we did, is this us? No, here's us. Okay, so we did the back yesterday. And then, I'm not going to waste your time doing 5B and 5C. 5B is a one-step problem using second orange. 5C is even an easier one, a one-step problem using first orange. So from now on, if it gets to orange, I'm just going to say first, second, third, and move on. I'm going to, what do you say, QED in math or whatever? Say, okay, you can do the rest. What does QED in math even mean? Some Latin? What does that mean? Gibby always did that, QED. Anybody know? Capital Q, capital E, capital D. They would do that at the end of a problem. Like,
Yeah, it's Latin.
does it mean like the rest is obvious or something?
It means what was to be shown.
What? What was to be shown?
Yeah.
I don't understand that. What do you mean, what was to be shown? Oh. I always thought it meant you can do the rest. That was my opinion. Okay, now let's talk about something that you're going to need help on. This 6.6 is 6.1 because that's the free body diagrams and the equations. That's the most important sheet in packet 6. But this 6.6, you can make a case, it's the second most important sheet in packet 6. Probably from this sheet, probably 80 out of the 300 points will come on the test, will come from this sheet. Now, number one, it would take us the rest of the hour to do that. I'm not going to do it. It's tedious. It's important. So for them, I made it homework. And I'm going to give them between 1 and 4 stamps for it tomorrow. I'm going stamp crazy, which it helps you in a way because it makes 6.4 worth more points. And you want that homework to jack up on points. So that means less damage from tests, right? All the points go into a big bucket. So the more points that are going in that are homework points, assuming you're doing your homework, the better for you. Anyway, so 1 to 4 stamps they're going to get tomorrow. And the way they're doing it, I bet they'll get 4 stamps. They're going crazy. Now let's talk about number 2. Let's look at number 2. Number 2, we started working it in first hour and then we backed off. And let me tell you why. Okay, so number 2, that's 60 degrees. There's your direction of motion. And we say the DOM is positive. So far, so good. Here is the weight of this cruise missile. It says it's 150 kilograms. So we got an mg down. Okay. Whatever. And then we have this 4429. I do not know. Someone asked, why are these numbers so? I apologize. I made this worksheet about a dozen years ago, and for some crazy reason, I was mad at them or something that they weren't using their calculators. So I started making my numbers all goofy. Anyway, so the thrust is 4429, but this is wrong. If you do it this way, it's wrong. Take a look. If I do this, I don't know if I can eat why. Well, it looks pretty good though. Can you put that in the freezer?
Yeah, I'm gonna eat a bite though.
Oh, take it. Just take the whole thing. You didn't have one?
No, I got it.
Oh, eat it.
Oh,
Well, it's yours. I don't
can
want
you
it.
talk to people?
Yeah.
Okay, thanks.
Yeah. Looks good though. So if this is the thrust, why is this wrong? We talked about this back on 6.1.
Because the thrust doesn't go directly in the same direction of the movement.
Yes, it can't, right? Why can't it? and there's no air drag, and there's no normal force. Of course, you have to have solid contact for normal force. We don't have that. But why can't the thrust go in the same direction as motion? Anybody want to offer that one up? We got some smart people here. Why can't you do why can't in fact every one of you are smart? Why can't we do that? Why can't we make thrust in the same direction as motion? That'd be an essay question. That's a pretty good essay question. And I'll give you a hint. It has to do with head to tail. Let's assume there's no air drag. Those are the only two forces. I know it's ludicrous, but let's say those are the only two forces, significant forces on this cruise missile. Why is this wrong?
Would it be because the summation of forces wouldn't add up in that direction?
Boom. So you are correct. And I think Sophia or somebody was jumping there too. I'm sure they're saying the same thing. That because you're adding in the weight. And so there's no way that you're going to add. So the T has got to end up being, and here's why we didn't do it in first hour. We started to, and then I said, man, we got bigger fish to fry here. We cannot sit here and waste. We could have, and you could still do it. T, and then this is going to be your MG when you add them up head to tail. Let me erase that one. I told the kids I'd explain it. Oh, I'd explain it better on the, okay, whatever. So I told them I'll explain it better on this video. So I'm trying to do a better job. I kind of ran through it real quick in class. Okay. You all actually get the best explanation of anybody, believe it or not. Because this is the fourth time I've gone through it, and I'm trying to be good. So when I add that up, ghost, when I do the ghost of the MG, then the resultant needs to be at 60 degrees. Now here's the hard part. Find that angle. You can do it, but we're not going to do it right now. That's my summation of forces, right? So, and that's the vector. Find that angle that the thrust, why am I calling it T? Oh, God. Crazy day. Force of thrust. There you go. Why am I calling that? I don't know why I was calling that T. So what is that angle from the horizontal? In other words, what is, and I'll leave us alone, I promise. We're going to move on. But what is this angle right here? Once you have that figured out, theta equals question mark. And you can do it either head to tail with a ruler and a protractor, or you can do it by components. It's possible, but that's a whole other challenge. I'm not saying it's not a good problem, but it's not worth it right now. Okay, so let's leave that alone. And what if you just leave it like that, you'll get full credit when I grade your packet. If you want to do it, work it all out, and then maybe post it to Facebook, and then even try part B. I mean, it's great. B is a very good question, but I may miss it because I don't have much time to grade your packet 6, and I kind of blow through it. So make sure you give me notes that, hey, I did this. Give me the extra credit for that. I try and pay you for the work you do. Extra work. All right. Now we get to the one that 70% of students miss. Every kid in first hour missed it. Second hour, about 50% missed it. Third hour, about 60% missed it. And they drew the free body diagram wrong. So here we go. This is our first introduction to inclined planes. And we'll spend today, we'll come back to inclined planes off and on the rest of the year, even in June, because they're really important. a 40 kilogram. So let's first go through and just look this over. We'll do this one together. I'm going to send you to the board here in a minute, but first let's look at it. 40 kilogram, there's our mass. Incline is 18.5 degrees. Once again, apologize. Why? What was I thinking? A tow rope is parallel to the incline and a tension of 170 newtons. So there's where I get my T. That is your tension. And then I'm adding this little bit when we kind of throw a little arrow at it. If it's a vector, throw an arrow in the general direction, and that is at 18.5 degrees. I was on a kick that year on sig figs, I think is what I was doing. I was trying to show them, you've got to give me 3, but then the 15's wrong. I don't know. F sub, this is a wagon wheel. So Emma Hunter was taking a test during lunch, and wasn't this problem, but there was a deal with wheels turning. She goes, is that FS or FK? And so I said, look, it's FS, because remember, where that wheel is pushing off the ground, that part compared to the ground is not moving. So that's static. That's the only part of the wheel that's not moving, is the part touching the ground. So FS, if it's sliding, it'd be FK. Assume that the wagon starts from rest. Okay, so their little keyword there, V naught is 0. How fast is it going after it moves? Okay, how fast? So we're trying to find V final, question mark. As it moves 80 meters up the hill, there's my delta X. This is really how all your physics problems should look. When you get to college, you just start diagramming the whole thing out. And in your mind, you're putting together your free body diagram. All right, so you don't need to get a ruler here, but here is our incline plane. Black. Okay, it's at 18.5 degrees. And yeah. So there's my theta. This is the reason why you showed up today, is this problem. This problem number 6. Theta 18.5 degrees. Fine. Now I'm going to turn the recorder off here, and I want you to draw. You don't need to work the whole problem. Just draw the free body diagram. And I'll give you a hint. There's 4 forces. Okay, 4 forces. And I'm going to guess there are 1, 2, 3. Okay, there's 7 of you. I'm going to guess that at least 4 of you will do it wrong. But it's fine to do it wrong now. Just don't do it wrong on the test, right? No harm in doing it wrong now. Okay, so I'm turning it off. If you're watching the recording here, why don't you hit pause, and we'll come back after you've had a chance to try it. All right, I'm pausing. Good grief, another Facebook point. You guys are safe. Zoom.
Io said it first. You didn't hear him.
Okay. Well, I'll give it to you both. Okay, and you give it to yourself. So there's the Y, and there's the X. See, I tilted the axis, and by doing that, I reduced my work by at least 50%. And you'll see why in a minute. Now, we're not done with the free body diagram, though. We still got the normal force, right? There is a solid contact here. And if you did this, you are like about 70% of physics students the first time they see this. You did it wrong. I understand why you did it, because you've been conditioned, like on all these car problems, to make normal force up, right? Boat, whatever. Well, not boat, that's buoyancy, but you know what I mean? Tennis ball hitting, their normal force is always pointed up. But no, normal means perpendicular to the surface. So if you did it this way, where the normal force is perpendicular to the surface, you give yourself a pat on the back. I would come around and give you an Insta stamp in class. your group. And they fight for those Insta stamps. Normal. So be honest now. Show of hands. Who put the normal force correct? I'm not going to give you any points for it. I'm just curious. And if none of you did, okay, we got one. That's about right. I expected one or two. So that's why you came today, because that's going to kill you on a test if you don't do it that way. Normal means perpendicular. Yes, it's contact force, but that's why they kept the name normal. So in your head that it's always perpendicular to the contact. Okay. Now we're ready to work this problem. I'm gonna erase some stuff. Now we're all right. My links aren't terrible. Here's something. This came up in class. Let me kill this stuff around here. Give me some room. Okay. Just erase the whole thing. Okay, because I got something. This is big. I noticed that a student, when I walked around, I looked at checking the paper, a student had, I'll show you something. You tell me why it's wrong. But a student had this. Okay. There's the normal. Then they did this. Boom, boom. Once again, they're trying to apply what they've learned. Normal force and mg are the same. There's no other force at an angle from this only mg. So why is that wrong? Let's go ahead and kill all that. But want to venture a guess on that one? Why is that? Why in the end congruent to the mg?
Because mg is going straight down and it's not.
True. Takagi, mg is going down. So they're not, to be congruent, equal and opposite. We know this wagon's not levitating. It's not sinking. But to be equal and opposite, to be congruent, and they have to oppose each other. They don't. Exactly. So let me get rid of that before I actually leave it on there. They aren't congruent. So you said, what? You mean it's levitating? No. Did I ever tell you it's this thing about a vector at an angle? I don't know if I ever told you that, but a vector at an angle is the hypotenuse of a right triangle. But to tell you the truth, it's more than that. A vector at an angle is the diagonal of a rectangle. I'll show you, huh? It's the diagonal of a rectangle. Actually, the mg is this diagonal, because you can use either one of these triangles. You can use it, whichever one's convenient. No. Oh, okay, fine. So, okay. I'm going to use, it doesn't matter. Normally you use the angle. Normally you use so that the part you need, like you're going to use that component. All right. I'm telling you, this is very important stuff. That's why I'm going super slow. I blew through the other problem so I can spend my time on this one. Okay, so there's and if you wanted to make the other one, like if you wanted to make this the right triangle, I wouldn't argue with you. I can see it either way. But really the one I want here is the green one. Okay, so now the next step is I need to write numbers. Shoot. What was that, 170? Shoot, I erased it. I got it here. 170, 15. Okay. So that's 170 equals And that equals 15. And I can't believe I can't remember. That was 40, okay, 40 kilograms. The M was 40 kilograms. Okay, so now let's go to the summation of forces. And once again, I'll pause it for a minute and let you do it. Okay, get the next thing, which is that, summation of forces in the X equals MAX. You do that one now. And I'm going to pause. This time I won't forget. All right, so we're back on. I told them that one little nugget there that I want to make sure you get is that the normal force is congruent to the y component, the tilted y component of the green right triangle. That's a right angle. Getting into some details today. Devil's in the details in physics. Okay, so now we do summation of forces in the X. All right, fair enough. I have T. I get all that one. O. DOM is positive. T minus static friction, because it's rolling, minus what?
mg sine theta.
Okay. But I'll give you that's fine. I'll give you a point for that. But mg, remember I said that for X, we're going to say that X is always cosine and Y sine. So I need this angle. I need the angle from the X. What is that angle right there? Little geometry 101 here. Hold on. What is that angle? If I extend this horizontal line out. This is all the stuff I talk about with my hands in that help video that you'll see today. This is 90 degrees, right? So what must this angle here be? This is a corresponding angle. This is a corresponding angle of this. So what must this angle be if it's a right triangle? What do the three angles add up to on a triangle?
180.
180.
180. So that's 90. That's 18.5. What must this be?
71.5.
71.5. So that angle right there is 71.5. Now what Io said is not false, and I would perfectly accept it there. He said sine of 18.5, which is the same thing as cosine 71.5, and therefore I don't break my promise to you that as long as it's X, it'll be cosine. But I will certainly accept sine of 18.5. And that equals MAX. Okay. And then if I divide all that by M, I have AX. Erase that. And then that is the physics of it. The rest of it, you're just plugging and chugging all the numbers in, and then you can get the rest. Okay. So I'm going to leave it at that. QED, whatever that means. QED means, you can do the rest. So yeah, the rest is orange too, right? You got what? Third orange in there, I think. Third orange. Okay. So that was a hard one. Now let's get to the back. Oh, I made third hour do this on their paper. Just keep doing it and doing it and doing it until this is in your brain, muscle memory. Okay. You see this all the time in physics on inclined planes. Because I know it's going to drive me crazy. And on the test 6B, I'm going to see I'm going to see this from students. I'm going to see this, 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 and this. No, don't do that. Normal is not always straight up. Okay. That's what the kid from Durant High School will say. And you got to correct them because you got to help these kids when you're in college. So the help video, I pick on Durant. I don't know. Nothing against Durant. The help video, I'll post in this, and it's me talking about what we just talked about with my hands. Now, the last thing we're going to do today, we got 9 minutes, just about right. We're going to get number 6 done. Number 4 we'll do tomorrow. That will lead us, 4 will lead us to general relativity, curvature of space-time, believe it or not, because elevators are huge in physics. Einstein loved elevators. Okay, so we'll talk about that more tomorrow. 5 will lead us to a whole branch of physics called statics. We've talked about statics a little bit. We'll be dealing with law of sines there. These are truss problems, truss. And if you're in engineering, that just sent a chill down your spine. But I'm going to show you a shortcut to this particular kind of truss problem. Okay, so let's go to number 6 now, because 6 is to help us work on more of this inclined plane stuff. So I didn't have them go to the board, but we worked the rest of the hour on their paper. They worked on their papers, and I worked on the board a little bit in silence. Sometimes we just turn a little music on and, work. Eat some Oreos. I got a parent in third hour that brings us Oreos, so we eat some Oreos and work on this. So here we go. A box sliding down the ramp is going to hit patches. It's a rough ramp, so we do have friction. So first off, you got to give me a free body diagram on this one. Three forces. Remember, tilt your axis. See, because in that last problem, if I didn't tilt my axis, if I kept X, Y, X horizontal, Y vertical, can you see where I would have, that would make MG easier, but now I got an angle on the static friction, I got an angle on the tension, and I got an angle on the normal. And then I got to deal with normal. Notice we never dealt with normal. It went away. Now, normal will come roaring back next week. It'll become important again next week. Next week, we talk more friction. Friction's basically chemistry. So we'll talk the chemistry of friction next week, and then all of a sudden, normal becomes important again. Number 6. We're down to 7 minutes here. You work, I'll work. If you're watching the recording, start working on it. I will work in silence, sort of. But first thing I do, tilt my axis. You think that's weird? That's magic, right? You tilt your axis. You know what we're going to do in a few weeks? Well, it may not be in June, but we're going to melt the axis. We're going to melt the x-axis. In math class, your teacher is all, oh, yes, this is XY. Oh, this must be XY. It's blah, blah, blah. No, you got to think outside the box. Tell them, boo. It is not just like that. I can tilt it. I can melt it. Okay, so I tilted here. I always do MG because that's comforting. I know what it does. Normal is perpendicular. I know it is congruent to the y component of that triangle, of this triangle that is produced, dash line there, of this virtual triangle that is produced. This leg, this leg here is congruent to the n here. That's going to be more important next week. I'm just telling you. That looks pretty good. These free bodies start to become works of art after a while. That, and then there's a friction back. So this time it's F sub K. It's not much, only 12.2 newtons. So a little arrow back. And you could do these head to tail. I mean, you can. You just got to really be careful on your measurements. And that's F sub K. Okay. And I'll make that a green right triangle. What we got left? We got about 4 minutes. Okay. Let's get some of the basics down out of the way here. Okay. That's important to color in that so you know which, so your mind kind of knows which right triangle we're dealing with. But like I say, you could have done this one over here and it would have been fine. Normal. That's the important, this is the important leg of that green right triangle, that leg right there. Oh, by the way, what is this angle right here? Shout it. I don't have the chat on. Go ahead and shout it out. What is this angle right here?
Would it be 65?
You got it. 65. Thank you, Sophia. 65 degrees, the complement to the 25. And that's always the case. That'll always be the case on inclined planes. So we go, okay, we're trying to figure out how long. So we're trying to find time. So summation of forces in the tilted X, equals MAX. Hey, is that box is sliding towards patches? Is that the positive direction or is that the negative? Because it's kind of downhill. That's why we say, and I lost my little icon. That's why we say DOM in free body diagrams. The DOM is always positive. So in this case, it's down the incline is positive. You want, because we're going to get to something called work. Maybe June and maybe the end of May. We may get to, I don't think we will, it'll be June. But work leads us to energy, which leads us to conservation of energy, which leads us to thermodynamics. So, but work is all about forces that are helping a problem and forces that are hurting. Energy poured into a system, energy poured out of a system, or draining out of a system. But so you want your things that are making things speed up. You want those to be the positive forces, and whatever's making the object slow down to be the negative forces, conceptually. Okay. If you're a big fan of James Joule, you guys heard of joules, right? In chemistry, that's where it came from. It came from physics. So in the 1 minute that we have, let's knock this off. So we have mg cosine 65 minus kinetic friction equals MAX. Once again, because I tilted the axis, the normal force went away as far as we're concerned in the X direction. And that is, I think you can take it from there because then it's plug and chug. You're trying to solve for acceleration. And then, then you use what? Second orange. Yeah, you're using second orange because you have delta X. You're trying to find time. Yeah, and you have a, so boom, at that point, then you'd go to second orange. Ta-da. Okay. We are now at 2 o'clock, so I promised you would be done then. I bid you adieu. You guys have a good day. Hold it. Okay, there's nothing I can think of that I had to tell you. The homework then to keep up with the class is number 1 on this sheet. Tomorrow we talk a little elevators and general theory of relativity. We talk a little statics. Okay, and trust problems. All right, have a good Wednesday, everybody. If you have a question, stick around. Okay, Takaki, you got anything?